One, may I request everyone to kindly be seated so that we can move on to the next session post-lunch. Pillars of Strength, Foundational Technologies for Defense Space Resilience. The discussion will delve into the foundational space-based technologies that form the backbone of modern defense system, driving innovation, operational superiority and security. For the same, may I call upon the chair and the moderator, Mr. Sudhir N. Kumar, former director, CBPO, ISRO headquarters, on the dais. The panelists for the session are Mr. Sakti Kumar R., founder and CEO, Orbit 8 Aerospace; Commander KJ Swaroop Kumar, Head Program Management, Agnikul Cosmos; Mr. Vikas Arora, VP Business Development, Logic Fruit Technologies; Dr. Ashok Saxena, CEO, Space TS; and Mr. Suhas Gopinath, CEO and Chairman, Global Inc. Over to you, Chair.
Thank you very much. Probably many seats are vacant. Anyhow, time will wait for none. The topic chosen by the organizers is the pillars of strength, the foundation technologies for space resilience. It's a very quite interesting topic and very wide, vast topic, and critical to understand and more critical to implement. So with that prelude, probably I think we can jump into the conversations, whatever experienced and bubbling speakers are going to talk about in the next 1 hour. Before that one, to set the context rolling, morning we had a very good conversation, the inaugural session by AVM Pavan Kumar and other dignitaries. And we were also understanding how actually this defense space is creating or deriving the support or some strings from the civilian space, which is obviously ISRO is one of the 4 or 5 famous and established spacefaring nations across the globe. Now the question is how this defense space will enable the space knowledge with the expert organizations, R&D labs like DRDO and ISRO. How DSA has taken birth out of it, out of the requirement, and how DSA is getting equipped itself to handle it independently. And what are all the who are all the stakeholders? What are the challenges behind? This probably I think sometime we can spend during this session of 1 hour, so that some deliberations can happen and give us direction also. To be more specific, let us say if you say the stakeholders, one is the 4. I'm considering space as one vertical: armed force, then air force and naval force, as well as the space force in the defense, how they contribute. Defense force is a merge of or as a mix of all the 3 forces sitting together and developing the space knowledge. But functionally, all these forces have got their own requirements and functional requirements, and they do listen to the different voices what is around, because they should know more about the other people who are contenders who breach this particular space and challenges our sovereignty, because the forces, the users of this technology are well informed, and their demands, expectations are much higher. This is one thing I have noticed in facing the defense challenges when we are making the problem statements, or when we are converting the challenges into problem statements and specifications. The users are very demanding, and this is to the sovereignty of the country. That means highest level of what you call definition of the requirements will be there. Then the second thing is enablers. Let us say you call it as space, ISRO, then labs, different labs, then different knowledge people on the systems technology front, DRDO, such kind of people who try to bridge the expectations with the ecosystem, which will realize and give them the system so that they can do their job in a better way. Morning you are seeing one, Mr. Sai Krishna was narrating in a beautiful manner how actually the new technologies will be enabled. The third vertical could be the executors. Executors could be labs again, individuals, startups, industry, where the expectations of the users will be understood in a functional requirement way, and the labs and the knowledgeable people, they will convert that functional requirements into the specifications and the realizable systems, and the industry, including even the government agencies, who will realize and put it into practice to meet the customer expectations. Here the different stakeholders, and more about that one is thanks to Dr. Ranjana. She was brainwashing me before coming onto the stage. The legal aspect is there. Lawyers and economists, they play a big role, which always we ignore in the space system. We always habituated for 50 years glory of civilian space, only one organization, incidentally, where I come from, have a glory of managing the entire system. See, under the government, no, legalities and other things will be taken care of by the inside system. The 4 or 2 additional stakeholders would be legal experts who make the system more robust, and but of course legal, when it comes, it is very complex to understand. Even the language itself is very difficult to understand. Forget about absorbing and putting into the specification mode. The economists. This economy only is driving the system. Otherwise, any industry which have to derive, they ultimately have to shelve something. So obviously they say, "Mera, humko kya lagega? What I will get?" Because it is irrelevant. See, passionate, then the attachment, then emotional attachments are all will not come into the business front. Who are going to realize? But if government has to realize, government's responsibility is a budget oriented. It is not profit oriented. And when government gives the budget, whether it is you are spending 100 rupees for getting the 1 rupee benefit today, it is immaterial. It is the sovereignty protection. We don't go by the economics. But ultimately the industry, when there are limitations with the government today. That is the reason space sector got opened up. Even though ISRO can do because of procedural constraints, because of so many resource constraints, because of so many reasons, the scaling up is not on the commensurate as it is expected. So that is why the industrialization, productionization come into picture. The productionization, when it comes, obviously the question is economy will come. Economy is associated with equal opportunity to the people, policies, reforms, then these SOPs will come into picture to give equal opportunity to the people. This is where exactly we stand in that transformation phase, where the space sector, defense space is going to emerge or going to grow independently, because we cannot put the civilian front and military together based on the international conventions, and many issues are there in import items, development, other things. So civil front and defense front has to be separated. There should be a line at least to demarcated, which for if not for the within the country, for the outside people to live it. Then the legal framework, the policies, the procedures, who does not do, what to do, what not to do, how not to do, who will be in the ecosystem. These are all procedural framework, in terms of policies, SOPs. Thank God that InSpace came into picture, and they have brought out very detailed way the SOPs, and that's where we stand now. After listening to AVM Pavan Kumar, he was talking about a huge expectation. He was talking about all layers, 3 layers. One is LEO, MEO, GEO, where today India, even though they have capability, ultimately how long it will take. We have been discussing these topics in my what you call knowledge for last 3 years or 4 years, when Aero Show 2021, if I am correct, when it was announced, defense challenges were announced, and 75 challenges we announced. ISRO also had helped or in terms of technology to shape this one, and now startups are developing the component level and composite level challenges. Fine. After that, actual production has to take place and we have to scale it up. After that, we have to have a huge what you call backup system to monitor. Let us say 100 satellites, 150 satellites are there. If you see the neighboring friends, maybe USA may have 100 to 150 satellites, China may have 70 to 80 satellites, Russia will have 50 to 60 satellites, Israel have this kind of plethora of the satellites that are there. But when the data is generated, the cyber issues, the cloud issues, the computation issues, the security issues, how actually a dashboard, who is a brigadier or somebody major who is sitting and operating the terminal, he will get to know what is the false alarm, what is the correct alarm, where to take, because that is what they are telling. The kind of red alert, when it comes, then only it will be sensitized. How that red alert, because for it is all individual. If I see red alert at one threshold level, for other person who is a bit more risky would be a different level. Some breaches would be there. So this is the ecosystem where we are standing and thinking the ecosystem should be like this. Who operate that? And in a very secured way. It is not that anybody can walk in and do something. And when, let's say, 100 to 150 satellites go up in the sky, both in the directions, who will manage the traffic management in the congested front, and how the data will be disseminated, if at all any tasking is there, how to task. Huge amount of data is there, where you store, how to convert them, how to become archives, and ground equipment, maintenance, operation. This is what the entire system has to be conceived in a big, let us say, envelope, and sufficient resources have to be done, and year on year additions, augmentations, modifications have to take place, and someone has to monitor all these things in a big way. So this is the challenge in front of us today in the defense space. And moreover, the international community comes into picture. If it is civilian front, not much. If international fraternity comes into picture, challenges, what is to be done, how to protect, then so many things you have seen. Even though our satellites are there, they are getting spoofed, or they are getting what you call jammed in the war-end technologies. And we have friends nearby. They are much advanced and intelligent than, I should say, not human brain wise, but resources wise. That is fact of the day. How to overcome them, how to bypass, how to surpass those activities. These are all the challenges when you talk about the resilience and some kind of the challenges what you see. Probably I'll go to the each and every panelist. I could see a couple of people in the launch vehicle fraternity, couple of people on the cyber security, as well as in the satellite front. So I leave only one point agenda in front of the panels, that in your whatever the domain that you have chosen, kindly introduce yourself, because I don't have much details about the speakers. I request you to confine yourself for 5 to 6 minutes. Rather, 5 minutes could be the better choice. And introduce yourself and speak out how this particular topic, given in your perspective, would add value. What are the challenges? What are the opportunities? And what is the way forward? So I'll start with Gopinath to start with. I think we can please kindly take care of the time, because organizers are under the tension for conducting this session. Thank you.
Thanks a lot for the introduction, sir. And I want to introduce myself as I'm Dr. Suhas Gopinath. I'm CEO of Globals, and as a company, we are in cyber warfare systems and cyber defense systems. And actually, specifically, we've done some research on the vulnerabilities that exist within the space segment and ground, and also across ground segment. And at least from a cyber perspective, if you have to make your space asset, space assets absolutely resilient, I think the focus has to be at least as a country. If we could adopt a framework similar to Sparta, which I was speaking to Rajiv Gambhir sir as well, of course, some time back, and it has to be similar to the MITRE attack chain. If we are able to adopt a framework similar to Sparta, which was introduced by Thales and also European Space Agency, where it identifies the TTPs that exist in space assets, and it's also very surprising that as a country we do not have a cyber range which is specifically focused on the space sector, and we got cyber ranges that is or to carrying out simulations of actually cyber attacks on the ground segment or space segment or it would link segment. I think it's absolutely need of the hour if industry and startups and also with the space agencies like ISRO, if they could collaborate to come up with a I would say a cyber range which could be open source at least for the space tech startups, so that at least they are able to test and if they're able to harden their satellites and also ground stations. And at least coming from on the cyber security perspective, I think space, with the fact that it's assumed that it's very complex, it's also taken for granted that I think cyber security to some extent it's put on the back burner. And I would not want to name specific organizations, but actually we've seen it could be in terms of the very cyber hygiene or the fact that there is a perpetual dependence of these agencies to buy the software or hardware from COTS. So, and when it's not proprietary, it's also prone for supply chain attacks. And we've seen in multiple instances. And of course, within the Ukraine war, it was a classic example where it was very unfortunate that the Viasat SATCOM terminals got compromised, and it was being abused. Nuclear warfare, and which also affected civilians as well. So I think ground station hardening and the satellite hardening has to be the focus. And if we could have a specific mechanism or a framework which is very similar to Sparta, where at least we understand the attack vectors that exist within the user segment, link segment, space segment, and the ground segment. And I've also come across one of the research papers by one of the professors at MIT, where I think US is looking to build a cyber weapon which is similar to ASAT, but it's called a cyber ASAT, which is very similar to the Shakti, which was launched by DRDO. But in case if we are weaponizing these vulnerabilities, and if there are ways where APT groups are able to bring down satellites or are able to turn on fail-safe mode or are able to turn off the avoidance systems, and if you are able to do a satellite collision, and the worst part with any cyber attack in the space is that it cannot be attributed at all. And we've seen APT groups aggressively targeting the Indian space agencies almost every day. And I think if we are able to focus on supply chain security and also proprietary frameworks.
Let us say now the fear is, even though the fear, internal fear could be when we order something to the supply chain, private supply chain, when they procure the items from countries like China, some malwares or some hardwares will be embedded into that one. See, is there any way that such kind of things prima facie can be taken care?
Yeah, I think the fact that if we're able to have cyber ranges, and if we're also having testing facility where we're able to reverse engineer these hardware or software, and it has to be a shared facility, of course, and it's very expensive. It's very expensive for every space tech startups to adopt it or for every space agency to do it. But if it's a shared facility in where the software and the hardware that they're procuring, if there's a mechanism where it could be reverse engineered and to identify if there
I agree with you, because the question is, when the reverse engineering has to be taken place, even to that extent, we should have knowledge to engineer it and ultimately do it. No, it is a concern.
I think the knowledge and skills do exist, but I think the infrastructure is something which is not there, and the most important is the intent. So if they could put cyber security in the forefront, And I think with ISRO, it's only a few years back is when ISRO has introduced a CISO at the headquarters. So yeah.
I agree with you. And maybe standardization, other things, which is again another topic which we are discussing. Probably standardization of supply chain, standardization of let us say equipment, and standardization of testing would help us in kind of thing. I'll go to Commodore Sarup. You please. I think somebody can help us to get a mic, hand mic.
Thank you, sir. Good afternoon to the august audience here. I'm Commander Swaroop. I come with a residual almost 24 years of experience in the Navy, largely with aircraft carriers. I was also associated with the Vikrant project, for close to 5 years, and so the word indigenization is really close to me, and that's perhaps the reason also when I joined Agnikul, when I got to know that they are in for something big, I jumped into this bandwagon, and currently I am the head of their programs. So speaking about Agnikul, we reciprocate the fact that it's almost custom made or tailor made for the defense requirements. Our motto goes that we should be able to launch anywhere, anytime, affordably. So I think the triplet, it quantifies that we should be able to launch a satellite on demand. So at any time. So on demand is that, like I need to launch a satellite in a particular orbit for a particular purpose. We can do that. How do we do it? Because we have gone in for non-conventional manufacturing methods. That is, we do 3D printing. In fact, we are the first company in the world to have a 3D printed rocket engine. So we can manufacture, in the current rate, 2 rocket engines every week in 72 hours. Roughly, so we can manufacture 2 rocket engines. That means every month we can launch some 4 to 5 satellites up. So going to space, it's like this: that the going to space should not be the toughest thing for mankind. That should be the start point of the cyber warfare and the resilience that we are talking about. Begins with how do I reach there? That should be the easiest thing for me to do. So the rest of the technology starts from there. Now, towards that, and talking about the technology, we have done the first, the maiden launch on the 30th of May. It was a suborbital launch, but we demonstrated all the technologies that we are going to put in for our orbital launch, which is scheduled sometime later this year. However, so what came to me as a pleasant surprise when I joined this place, we are incubated at IIT Madras, is that technology is not the challenge. We have been struggling to have a good pump and a motor for the last 20 years since the time I joined the Navy. But herein, we have printed a rocket engine, we are manufacturing a cryogenic pump, we are manufacturing an ATF pump, we are manufacturing a BLDC motor at 50,000 RPM at 100 kilowatt power rating. It's there. But, so there is a gap, this gap has to be bridged. And who bridges this gap? I don't think technology is a problem because data acquisition systems, I've spoken to multiple people in this domain, and what I realized is that it is not the technology, technocrats, or the will of in fact, the MSMEs and the startups. It is the mature domain which is existing, the interface which has to happen between the government, the private, the MSMEs, the startups. Today, technology can be developed, but where do I leverage it? How do I leverage it? We are all talking it, in silos. While yes, we are still in the infancy. InSpace has done a great job in nurturing startups like Agnikul, and we have done it. Now, it was not possible. It wouldn't have been possible without ISRO and InSpace giving us the space to do it. But when it comes to defense, we need to have the will to do it. Now, we are talking about technologies which are changing by the day. By the time I clear a file on paper and get it going, it takes 2 years. In 2 years, we are already off. The technology is too much, too far. And who is going to fund these upcoming startups? We are at the beck and call of the investors, not at the government. So I think it's a loud call. I do this because I have struggled at the other end, being an operator on Vikramaditya, which was an induction from the Russian Navy. Before that, I was on Virat, which was from the English Navy. And then we have now, of course, indigenously built IAC. However, with a lot of inductions, foreign inductions. So this dependency has to be cut down. So in the words of Director IIT, very recently we had our 7th anniversary. So there is this 27-year-old lady called as Ms. Uma Maheshwari, who was the mission director of our first suborbital launch. So he says that, you know, if a 27-year-old lady can call off a mission, you know, in the last minute, there is ISRO chairman sitting there, there are a lot of dignitaries sitting there, and the launch was supposed to happen, and there was a fault in the automatic launch, computer. It said there was an error. So he called off the mission. But that confidence of calling off that mission came because everything was developed from womb to tomb by those 26-year-old gentlemen there, you know, and the women over there. That confidence is what will come into defense space if we nurture it from the womb to tomb. So that's the loud call which I would like to make in this August audience, that I don't think technology or intelligence, the will of the industry or the MSMEs or the startups, but to meander how to go ahead with whatever I've developed. I really don't know how to integrate it. I'm really knocking at the doors. I'm knocking at the corridors. So who is supposed to do this? That's something which I would like this audience, and of course I thank SIA for having given this opportunity for all of us to come together in this forum. And sir, we have quite an experienced this thing from ISRO which has come, and ISRO, I must acknowledge it, that they have done a great job in nurturing and opening up the doors for the space at this juncture.
Thank you, Mr. Sapur. This wherever it comes, the most critical part is launch vehicle, and launch vehicle system is so complex, which we have seen for last 20 to 25 years. Whatever you do, the unknown element is unknown would be more. So thankfully, to the extent possible, known unknowns can be bridged. Unknown knowns also can be bridged. But unknown, what is going to happen, that is very difficult to bridge. That is what everybody says, it is not rocket science. Okay, let us hope that the technology part and sufficient support, we will get it. I will go to Shakti. Shakti is in space manufacturing, and quite interesting things they are doing at Orbitate. Shakti, you can introduce yourself and speak on what your actions, which are more relevant to the defense space, how you are going to support, your technology is going to support.
Okay, thank you, sir. Thank you, my dear panelists and organizers. Honored to be in the panelists, actually. Thank you so much. As Saris mentioned, actually, I am Shakti Kumar, founder and CEO of Orbitate. Orbitate is actually into the on-orbit servicings, especially is on-orbit refueling. So we are the first company in India is doing on-orbit refueling, and recently we have done that zero-G test at Florida, and from India is the first time we are demonstrated our capabilities. So where these capabilities can be used or supported to these defense or something, where the defense are defense coming to the strategy or so-called a tactic. So always they'll go for defense, and they go for movement. So take it Army, take it Navy, take it Air Force, they'll do the like anything. Actually, they'll go for one place to one place. The Army, they can go from one place to other end, and Navy, they can go to other sea to other things. Air Force also like that is happening. But defense also has launched satellites, but whether it is moving, it's moving in only one orbit. That is because of they have limited fuels availability. If what is the increase of competition and emerging, it is a lots of threat is coming up from that neighbor and other countries. So we have to identify that solution to save our space assets. How do we save it? So it's actually we have to save from in space itself. So how do we do that? So the space has to, satellite has to be, defense satellite has to be do that revisit lots of times, revisit to again and again to this same trajectory and all those things. It's needed lots of fuels. So that is what Orbitate is coming for. We do that on-orbit refueling for that. In orbit, in LEO and MEO and GEO as well. So where that sustained space maneuver is actually, it is a practically, it's approved all over the US Space Command also it's approved. But whether it is implemented or not, no. It is implemented where it is US Space Force and even UK and China also started their capability of, they are checking their capabilities of maneuvering in space completely, in all over the things. They can do the orbit changes and shifting and all those things. Whether that India is actually started, yes, they have started recently, they are announced it, and they are testing that capabilities actually. ISR also, tomorrow is actually our big day. This will help us for more proximity, more maneuverability and all those things, this docking. So that is what we are also doing is actually. So how we can do that and how we can support that defense. So we can able to, we have developed our own patented docking and refueling mechanisms. That is what we done recently, the test at 0G conditions. And we are also developing our own tanker satellites. A tanker satellite is actually, it's a fuel loaded satellites. So we don't have any payload. So the payload has only RPO and docking mechanisms. And you can take care of your own, defense and all those things. They can take care of their own business of, the surveillance and other revisiting, all those things. So we can able to do the refuelings. So there is no worries about do that maneuvering in space. So there is a hesitation is happening nowadays, and even US Space Force also recently actually done that many things, but they failed it, and they are moving into the on-orbit servicing. That on-orbit servicing is actually on-orbit refueling, so that they can do the lots of maneuverability. That maneuverability they can do without worry about the fuel. So the fuel is important. So without, you have the technology, you have the everything, but it is actually you can able to do only very limited time. Then it's, what is the things? Actually, we have to use that technology for longer time. We have to use that resources for longer time. So it's needed to use that. We have to do that life extension. So that is what Orbitate is doing. So we can able to do that. We are closely working with the defense, and the defense also is supporting a lot, and especially the ISRO in space, and SOIS also is doing that, lots of support from that side. So that's why we cleared that recent test, and we are going to, first time in India, we are going to do that this coming months, docking and refueling in space. Thank you.
Thank you, Shakti. I think rather than removing the mess, avoiding the mess is another important subject probably. I think docking and refueling is one subject. In the days to come, to manage the traffic and to curtail and curb the traffic densities, it is one of the best method, I think, emerging and transforming area. Thank you, Shakti, for sharing. I'll go to now Vikas. See, you are in the embedded systems and software. Probably first my question is how to take care of the hardware COTS for a secured means. Probably I think you can throw some light, I wish.
Sure.
In addition to what you are going to talk.
Yeah, so first of all,
you can use it.
I think
Okay, fine.
Yeah, so first of all, thank you SIA to giving me this opportunity to be part of this discussion panel. Yeah, so thank you SIA, and my greetings to all the decorated officers here, and also the government officials and my fellow technology enthusiasts and the innovators. So my greetings to all of you. Myself, Vikas Arora. I have been into R&D for around 20 years. Have been working on various high-speed digital solutions, primarily working on the products. Lately, I have been working with Logic Fruit Technologies for the business development and primarily taking care of the India aerospace and defense business side. About Logic Fruit Technology, it's a startup which is around 15 years old, and it was started by a group of technology passionates, and we are still largely a technology company. We are not into a lot of business prospects. We love technology, and we try to deliver best-in-class high-speed digital solutions overseas and in India as well. We are working with a lot of defense labs, ISRO and DRDOs, quite aggressively this time. Prior to that, we have been focusing on various overseas customers as well for the test and measurement solutions and high-speed digital solutions as well. Now, coming to the aerospace and coming to the foundational technologies in defense ecosystem, I think there are majorly what we are focusing on in SATCOM. As you know, it's more about the time criticality, where whether it's about command and control, or whether it's about navigating the troops or the logistics. One of the important thing here is the high-speed digital communication, and that's our forte. And we are trying to build high-speed digital communication protocols as well as FPGA integrated solutions, because that's the real-time processing power is provided by the FPGAs. Another thing is important when it comes to the SATCOM, when it comes to the security. It's about the dynamically reconfigurable hardwares, and where FPGAs plays a very major important role in order to reconfigure it in real time when we see any fault or any misbehavior in the system. Coming to the surveillance and observation, here we see the data intensity is the key, because a lot of satellites and a lot of electronics are being deployed into the space, which means a lot more data with high resolution, for example, images, various data coming from various sensors, radars, sonars, and here the data is the key. And for data transfers, it takes a lot of energy from moving the data from satellite to the ground stations. Here, the system should also have the energy efficiencies, and the key important factor there is the miniaturization, where we are actually very good at. We put a lot of logic into the system in smaller real estates of FPGAs and hardwares, so that the overall electronic real estate is also small. As the world is moving towards more small satellite constellations, this becomes more important, because not only having the ability to launch satellites at a higher speed, but also able to have it in a lighter, faster manner, where this miniaturization concept of having the most of the data processing done in a very, very light manner is becoming very, very important. That's our forte, and we are also focusing on that. Now, coming to, for example, images, we have built space-grade image processing boards, and sometimes back, but we are focusing back again. The key here is when it comes to images, there is high-resolution images are being required by for example, the modern AI/ML systems, right? And but the conflict here is that we cannot process we cannot afford to have all the images and data sent to the ground station, because we need sometimes decision made in the real time. And also sometimes the data is not, all of the data being sent to the ground station are not useful. So what we are focusing on is to build edge computing solutions where we have intelligence in the satellite itself, that what data needs to be sent to the ground and what should be processed there. that gives two benefit. One is you are saving the energy as well, because it's energy intensive task to send a lot of data. Also, you are making quick decisions by splitting the data processing between the ground stations and the satellites. Now, another aspect of defense space is about the intelligence, which we all know that the electronic intelligence, right? So ELINT. So here our focus is not just about deploying the machine learning models in terms of images or data from the sensors, but about applying the machine learning in the data processing itself, data signals that we get from various sources. It has to be expedite to make the decision, because they are not human readable, right? So there has to be some machine learning models which infer from the coming data from various sources in defense ecosystem. So that's all our focus on. Apart from that, what we see as a challenge or the opportunities in defense ecosystem is about scalability, because as we see more and more electronics in the space as well as in the ground stations, so it's hard to actually scale until unless you are in a cloud, right? I have seen in some of our customers, we were working on a problem that they had a huge ground station, and they were facing the problem to expand it. And you can take some probabilistic estimation that how much data processing, how much compute power, how much memory, how much storage you need, but it's going to surpass always, because the speed of data processing requirement is quite high. So where there is a need of data segregation, where the most critical data is being processed at the data center itself, and here the private clouds can take a role where less time constrained data can be sent to the private cloud. Of course, there will be a security concern, right? We need to have robust encryption and decryption modules deployed there. That is one thing. The scalability is both on the space and on the ground station as well is a really good opportunity for us. Like we were talking earlier, that it takes a lot of time to build the system and launch it. I mean, that is something our concern is as well. We have been a bootstrapped company for quite long, and recently we got an investor, and investor wants us a quarterly revenues, right? And in defense, it takes quarters to get things done. Even the project gets started, right? You need to work a lot with the labs to build a case, and then it comes, the files goes on, and then But investor is asking for the revenues. I mean, that is something I would like to request here for the our government officials and the forces. Decorated officers as well. I think there is a need to have a public-private partnerships that needs to be expedited. We have been trying, but it's still far away from the manifestation. Apart from that, I think the future in India should also be having the private-private partnership. I mean, we at Logic Fruit Technologies, we don't believe in competition. We believe in collaboration, because we see there is a lot of things to be done in this space, and there is no need to compete with each other, but rather than small startups can come together. And of course, we know our strength, and you know your strengths, and then combining these strengths, having a collaborative approach, and having a solution build up together. Because we are majorly a building block providers, so we don't build the whole system by ourselves, right? So our solutions are, for example, SPCs, SMFTs, or other image processing boards. They go into a larger system. I think that is one approach. But public-private partnerships between labs and the startups and the bigger private players also. I think that is something we need support as a startup, and I think other startups also need that, right? Now, we talked about the scalability. I think redundancy is also important in space sector, right? Redundancy is when it comes to having a resilient system. So, for example, we have been working on multi-path data processing and data communication system, where once one channel is down, then the other channel can take up, right? That's the communication side. But again, on the satellite side as well, we need to have payloads deployed at multiple, exactly the same replica of the payloads, and it requires to again, coming back to the speed, to have it built, launched in a small amount of time. So redundancy is both important in the space as well as, of course, data center redundancy is quite old now. I mean, they have mastered it. I think the redundancy in the space, again, coming back to this group of small satellites having the same payloads deployed in all satellites to avoid the fault tolerance or any other situations. So that's another important point. Apart from that, I think security, we talked a lot. So that's
Thank you,
all I
thank you,
have to
thank you, Vikas.
speak from the logic fruit.
Thank you.
technologies we have.
You
Thank you.
brought out very good points. One is miniaturization.
Mm.
Now, thanks to the government of India for the semiconductor movement and scaling it up, probably I think FPGAs, ASICs, such kind of things should take more. I feel more startups. Space means any startup, they first wanted to come and do the launch vehicle.
Hmm.
Sorry to they're all early people. I could see everybody, I'm doing reusable launch vehicle. Somebody has seen it, reusable. What is that reusability? I have picked up something, satellite or some small thing fallen, they have recovered that, they call it as reusability. See, this passion of telling, as I think startups, it's as an elderly advice, it's not a caution, it is an elderly advice. There is much to develop. If you develop a sensor, probably automobile sector requires more sensors similar to, but you will qualify for space. Downrating that one, you can use it for automobile. And international markets. So probably startups should think on subsystem level or a package level rather than telling that, okay, I will do satellite, ISR satellite across within no time. Okay, fine. Intention should be good. You slowly scale it up. Because especially when we are in the space front, we know how much time it takes for qualifying a system, whether COTS, is it okay for satellite, he is telling radiation environment when it goes. If something, you cannot go back to the space and repair it and put it back. The cost is so much. See, veterans like Subbarao sir were there who soiled their hands in making the repetitions. But ASICs, FPGAs, even small MOSFET, RF connector, you have to import. Please concentrate, startups, the message, please concentrate on such kind of items, because government also would be very happy to give small amounts so that more number of employment can be generated, rather than telling that I will develop a reusable launch vehicle, cryogenic engine, liquid methane engine is good. I wish that they should have, but scale it up. I think this message is very important. In fact, when I was driving in ISRO indigenization, there are more than 250 items, even memory cards we don't have, glues we don't have in India. N number of, let us say, items are there in electronic front, where multiple applications are there, not only in aerospace, space, defense, automobile sector, and even agriculture, IoT, such kind of things. Today we don't have proper navigation, let us say, gadgets for our own military systems, our own vehicles. So these spin-offs have to be explored, and when you do concentrate more focusedly, look for scale of let us say volumes, and definitely that would be affordable. Probably whoever is aspiring startups are there. My advice as a senior colleague, please concentrate on those things and develop a small thing like a cottage industry is what China does. Every house has to become a cottage industry, where a small item you will develop, but put it in lakhs. Go to industry, MSMEs or industry for production support. Don't venture into, because you will flare it up and investors will come after you. I'll put 100 crores, I'll put 200 crores. And incidentally, I was listening to Jeff Bezos' interview in Facebook. He was telling USA, this risk capital is very high. They say they know that 10% of the success only is there, but still they pour money. I do not know the reason. Maybe they may have billions of surplus fund where they wanted to invest. But the question is, when it comes to the reality, where we go, I think this transformation is required. Startup is a very new buzzword. Everybody would like to come. Space means satellite or launch vehicle. Other than these two, nothing is there. Okay, let us confine ourselves to Vikas kind of people, high performance computing, quantum, secured communication, even modems are there. Today, how much cost modem is costing to us? So repeatability is not there, affordability is not there, then market will not come. I think we'll go now to the very interesting, let us say, space TS. TS stands for Technology Services?
Transportation. It doesn't stand for anything.
Okay, I'll call it as, because I was going through your company profile. It is more like capacity building. I'll go to Dr. Ashok to share how he is helping the space community to grow. Dr. Ashok.
Thank you very much. First of all, I would like to thank SIA for giving me an opportunity to be a panelist here. Thank you. I also want to thank all the distinguished speakers who came before me, because they set the tone for what I'm about to say. You know, I heard words like evasive, repair, reconfigurable, maneuverability. This is music to my ears, because this is all what our company does. You know, we are building a highly modular, maneuverable, multi-mission vehicle, and it can be used both for defensive as well as offensive defense operations. You know, so all the things that people have been talking about, I think we are implementing many aspects of them. Now, having said that, as a starting point, I'd like to focus on the topic, which is resiliency. Okay. Now, having been a space cadet since I was 7 years old, I'm very much into orbital trajectories. You know, so depending on if you want to see where you are going, you've got to know where you are and where you've been. You know, so with the expanding on what General Pannu said, the Outer Space Treaty was signed in 1967. And there are things that it covers and there are things that it doesn't cover, and that's why the question of resiliency comes up. You know, now some of the things are not pertinent, because in the Space Treaty they said you cannot assemble armies on the moon or on other planets. You know, but the ones that are close, that are relevant, are what's in the lower Earth orbit. And the Space Treaty does not allow for any nuclear or weapons of mass destruction, but it allows for other types of weapons to be collected and used in space. And in particular, it also includes kinetic weapons. You know, so that's where this thing of resiliency comes up. The second significant milestone, if I may say that, is the first space war. At least that's what the commanders in the field called it. The first space war was fought in 1991. It was the Gulf War, where there was tremendous coordination between the space assets, the ground, and the Air Force in order to conduct fruitful operations, whether it was weather forecasting for dust storms, Earth observation, communications. The so-called first space war was fought in 1991. You know, coming back to resiliency, I'd just like to take a minute to define what it means. Resiliency means it's the ability to recover from a failure to an acceptable level of operation. So you do not have to come back to the same level of operation, but as long as it is an acceptable level of operations. Now, along with this resiliency, what people do not talk about is a very important thing called reconstituent. In order to reconstituent something, you have to be able to come up with the same level of performance by adding something. It may be a launch of a new satellite, It may be bringing online a new ground station, but these are all elements of reconstitutionality. And it's a duality because the more reconstitution you have, the less resilient you have to be. Now, I want to touch briefly on what are we being resilient against, I mean, what is the threat? The threat could be natural, and it could be from the enemy. A natural threat is from, let's say, the space weather. And from the enemy, it could be simple things like cyber attacks that we've talked about. And it could be nuclear explosions. They could be high level or high orbit, small nuclear explosions that set out electromagnetic waves, or they also leave electrons around so that because of radiation, your asset could die, And there are many other types of threats in between, They could be directed energy weapons, which are lasers. They could be electronic warfare. It is a very valid thing. They could be direct kinetic weapons, like a launch of a missile directly to the satellite, and they could be attacks by enemy satellites themselves, by the bad guy. So there are many types of threats that one has to be resilient against. The topic of our discussion is technologies for resiliency. And in a broader sense, I'm going to use the word technology to cover a number of areas. And because resiliency, in most cases, is protected against by architectural elements and not just by technology. There are some parts of it which are based on technology, but most are architectural, For example, and there are 3Ds and 2Ps that constitute how you address resiliency in the space warfare, One is disaggregation. We put either functions or sensors or missions on different platforms. So this way, one person cannot down, an enemy cannot down the whole satellite, and even if they do, you only lose some of the function. The other is distribution. An example of distribution are the GPS satellites. So you have distributed that capability into a constellation, and if one of them is attacked, it's a high cost to benefit ratio for the attacker. You don't lose much of your capability, in fact, very little. And the third D is for diversification. Now, one of the things that has been touched on in this conference earlier is how people can collaborate with foreign countries, how the defense agencies can collaborate with civilian and commercial, because if you want to get, let's say, imagery data, you can get it from any of these sources, and they all help, okay? So this kind of diversification is another way of getting to resilience, In terms of the 2Ps for resilience, one of them is proliferation, and the other one is protection, In proliferation is very simple. You just put multiple satellites or multiple ground stations, and each one can take on the full functions of another ground station or another satellite. And the one that is really more technology oriented is the one that is called protection, okay? You can have hardware hardening, you can have cybersecurity hardening, and so on and so forth, There are built-in capabilities for detecting attackers, and maneuvering, okay? And somebody earlier on mentioned about accuracy and speed in maneuvering, That's one of the strengths of the space vehicle that we are building, We are also doing quantum encryption, quantum-proof encryption. So this way that, even when quantum computers come along, then we'll be able to downlink the data securely, So these are all the things that we are doing on hardening. Now, if I had some time, I can talk about how we can use resilience for a system that detects hypersonic glide vehicles. If you have the time, I can get into that.
We should allow one or two questions because
Okay.
privilege should be given to the speakers because
All
I
right,
got
sure.
a call another 5 minutes we have to conclude.
Okay.
If any questions are there, we can take. Yeah, please.
Namaskar, sir. My name is Devesh Upadhyay. I just want to club 2 points of Mr. Sudhir and Mr. Sarup. That we are very well on the track of manufacturing small components, and we are supplying dry lubrications to Indian Air Force. I just want to ask Sarup sir that he has told that technology is not a challenge. That's correct. But those technologies which are accessible, what about the technologies which are not accessible? If a company is manufacturing or synthesizing these technologies here in India, what is the acceptance rate or what is the vision of a company like Agnikul to accept or test these products for their application?
Good. We'll take this one.
Thank you. Yeah, thank you. Thank you for the. Since we are still in the infancy, like 7 years for a deep tech is still too young for us while we have done the launch. But yes, it is with the residual expertise which we have taken from ISRO. And also along with that, we have also taken their vendor capital. So I would not spin a word on that because we have to depend on that vendor capital. So it's not easy to step on into a new lot of which we have started. In fact, after I've moved in, we have slowly started moving in at least into the structural parts, not yet into the electronic parts. But we are not, we are wary about it, and we are opening up to larger segment of. In fact, we are now started moving in collaboration with startups for. I would like to speak about, sirs, this thing that at component level, we are around 80% of Indian made by Indian companies. In the last launch, we did a study of how much of Indianness is there in that mission which was done. So 80%, while 90% has been designed and developed by Agnikul, but 80% of the components were made in India, and that balance of 20% is dependency on. I must confess, but it is on the chips and the batteries.
Good, thank you. I think
20% of the thing is of a higher cost. What my experience says, it's of a higher cost.
Yeah.
So though it is populated as 20%, but it is affecting more than 80% in the component. And great appreciation on developing a high-speed pump. I've been witnessing that pump since long.
Thank you. Because of the paucity of time, we cannot handle more questions. I profusely thank all the panelists for their good amount of insight for this session. I thank SIA also for giving us this opportunity. Thank you.
Thank you so much. Yes, we can have a group picture.
In the meantime, you can announce next.
Thank you very much, everyone.